All right, let's get into it. Today, we're going to pull back the curtain on large language models. We're going to follow the incredible journey of an AI, almost like it's an apprentice, starting from a tiny spark of an idea all the way to the powerful assistant you might be using every single day. Let's do this. It really does feel like magic, doesn't it? You type in a question and boom, a perfectly written, coherent answer just appears out of nowhere. But how? How does it actually work? What is going on under the hood? Well, that's the big mystery we're going to solve together right now. So the life of our AI apprentice starts with something surprisingly simple. I mean, forget all the complex reasoning or deep understanding for a minute. At its very, very core, the model has just one job to do. And that one job, it's just to predict the next word. Seriously, that's it. When it sees a sentence like, "I love the food here," the model's entire existence is focused on calculating the most probable word that comes next. It could be amazing or delicious or maybe great. Absolutely everything it eventually learns, all of its power, stems from this one fundamental skill. And that brings us to the official kind of textbook definition. A large language model is a neural network trained to predict tokens, which for our purposes are just words or even pieces of words. But the part to really focus on here is that it's a prediction engine, a really, really big one. So how does this simple word predictor get so incredibly smart? Well, it gets sent to the biggest library you can possibly imagine, the entire internet. This is what we call the pre-training phase, and it's where our apprentice goes from being a simple guesser to, well, a worldly scholar. And the scale here, it's just mind-boggling. I mean, a model like Google's Gemma is trained on up to 6 trillion tokens of data. That's web pages, books, chats, articles, even computer code. To put that in perspective, that is a completely incomprehensible amount of information, all fed into this model for just one purpose. And yep, that purpose is still just to predict the next word. But here's where the real magic happens. By trying to do this trillions of times, the model is forced to build an internal map of how language and really how the world works just to get better at its job. Think about it. To predict the next word in a story about Paris, it helps to know the Eiffel Tower is there. To finish a line of code, it has to understand programming logic. This is how it starts absorbing grammar, facts, and even styles of reasoning, all from that one simple goal. Okay, so our apprentice has now, for all intents and purposes, read the entire library. It's incredibly knowledgeable, but it's not actually helpful yet. It knows a lot of stuff, but it doesn't know how to follow your instructions. This next stage, fine-tuning, is kind of like its first job, where it learns how to apply all that knowledge to specific tasks. So how do we do this? It's a process called supervised fine-tuning. Basically, researchers give the model thousands of super high-quality examples. They show it an instruction and then show it the perfect response. It learns, okay, when I see a prompt like, "summarize this," I should produce a summary that looks like this. It's learning to be a helpful assistant, not just a machine that finishes sentences. Now, having a powerful AI that can follow instructions is amazing, but we also need it to be safe. We need it to be aligned with human values. This step is absolutely critical in its education. Basically, we have to teach it some manners. We want it to be helpful, for sure, but also harmless and honest. And this is done using a pretty fascinating process called reinforcement learning from human feedback, or RLHF. It's basically a 3-step dance. First, you ask the model a question, and it gives you a few different answers. Then a human comes in and ranks those answers from best to worst. This one's great, this one's okay, and this one is just bad. Finally, those rankings are used to train a totally separate reward model, and that reward model's only job is to learn what humans like. The main AI is then trained to generate answers that get the highest possible score from that reward model. And that's exactly why alignment is so important. This is the process that steers the AI away from making up stuff or generating harmful content. It's really all about making sure this incredibly powerful tool is genuinely beneficial for all of us. So at this point, our AI apprentice is knowledgeable, it's helpful, and it's aligned. But there's still one more level to unlock: true reasoning. And what's wild is that the key to unlocking it isn't just in the AI, but in how we talk to it.
I mean, this is a really common question, right? Especially for things that require multiple steps, like a math problem or a logic puzzle. And you've probably seen this. If you just ask an LLM a word problem, you might get a very confident and completely wrong answer. So how do we get around that?
Okay, just look at this comparison. On the left, we ask the question straight up, and we get the wrong answer. But on the right, it's the exact same question, but we've added just a few simple words to the end of the prompt. And look at that. Suddenly the model lays out its entire thought process step by step, and it gets the correct answer. So what's the magic phrase? It's this simple phrase, let's think step by step. This is a famous example of what's called a chain of thought prompt. All it does is encourage the model not to just jump to a conclusion, but to actually write out its reasoning process, breaking the problem down into smaller pieces. And this technique dramatically improves its performance on all kinds of complex tasks. It's less about teaching the AI how to think and more about prompting it to show its work. So there you have it. The journey is pretty much complete. From a simple engine that just predicts the next word, our AI apprentice went through this massive pre-training. It learned to follow our instructions, it was aligned to our preferences, and finally, we learned how to prompt it to unlock its own reasoning abilities. So, when you step back, what have we really done here? We've taught a machine to follow the patterns of human thought. But as these models get better and better at reasoning, you have to wonder, what happens next? What happens when their thoughts start to lead us? It's a pretty fascinating question to think about as this tech keeps pushing forward. Thanks for joining me.